versus the embryonic age. The 2 weeks difference. Okay? You can read it. And I'll also explain to you over here, a gestational age 4 weeks is equivalent to 2 weeks of the embryonic age. Okay? So what are the specific objectives you have to do? Explain the gastrulation. If I say, what is the gastrulation? It is the differentiation, formation of the germ layers, the ectoderm, mesoderm, and endoderm. Describe early tissue formation, derivatives of ectoderm. We are doing only ectoderm today. Only ectoderm. Remember that, not mesoderm and the endoderm differentiation. So I can go, quickly. I bypass this. We'll come back to this. Okay. So, how does epiblast differentiate? You can think about it is through the primitive stage is very important. That line is there. Then is the primitive node, primitive pit. What are the mesenchymal cells? These are early cells, we call mesenchymal cells. How does mesoderm and endoderm form? This is the next week program I'm going to do. What is a notochordal process? I explain this is an axis, okay? Now you should see some pictures over here. I'm sure the pictures should be coming as well. I'll come back to this a little later. Yeah, here is a picture that you need. Now, let me orient you a little bit over here. This is what you see over here on all the epiblast. This is the primitive strip is coming. Then the primitive node is coming, and the axis which is coming from the mesoderm, that is basically the notochord. So these are notochordal process. And the tube epiblast, the ectoderm is already folding now. You can see the folding has already taken place. Can you understand the diagram here? The folding already taken place. The folding will be much more apparent. This is showing the same thing. Now you can see the cells are going through that. Can you see it? That is the primitive pit, and the red color is the mesoderm, yellow color is the endoderm, and the top color, which is the over there at the very top, on the top, this is the ectoderm. So ectoderm, mesoderm is a red color, and all happening because of the primitive pit. The cells are going through that. It's a very, and if I leave you like this diagram, these diagrams are not good. I don't like it. And I don't like the students to have a half idea, concept. It's a full idea, full concept should be there. Very easy. Compact cells, they disintegrate because of the WNT gene or the TGF. Then there is a primitive pit there, okay, and it falls down to form the mesoderm, etc. And now we are talking about the ectoderm one at a time. Ectoderm will be just a folding little bit tube, and the tube will be growing to form the brain, spinal cord, and the skin, and the neural crest cells, okay? So this I'm coming to you in a bit. Other things I'll explain to you a little later. Now, the important thing, I'll show you a diagram that why are we doing it. That will open up your mind. So why we have to know this? There must be some clinical reason. I'll show you in a minute. This is the reason. I now walk like this. This is the reason. Because unless I show this, hang on please, unless I show this picture, you say the world Dr. Paul is saying, who knows what it is? This is not medicine. If this is not medicine, what is medicine? So what is happening is the cells which are supposed to go through the primitive pit, they are stuck. So a baby is born with everything is there, like the scrotum. What do you expect in the scrotum? Testis. Very good answer. He knows that the testis is present in the scrotum. But if you find a hair cell, some brain cells, some other intestine over there, then you know there is a problem of the primitive pit. It is actually the primitive stick, primitive pit, primitive node problem. Okay, this is called teratoma. Sacrococcygeal teratoma. So teratoma is possible because if the cells are not differentiated properly. This is just to wake you up, to show you that we can have the babies with a bigger problem because the cells are not differentiating properly. Is that clear? Hang on, please let me. I have to quickly finish a couple of slides. Now, I'll just only 3-4 slides maybe, okay? But I'm trying to now emphasize, how the ectoderm is slowly forming the tube, okay? Look at this carefully. Now, this in my diagram, or their diagram, this is the notochord over here. Okay? And this is the ectoderm. Okay, you can see the neural processes. This is basically the ectoderm. This is the mesoderm, and mesoderm has the notochord. It's written over there, notochord. So it is attracting the ectoderm. See what is happening now. Can you see it's bending? Say yes to me.
Yes.
Okay, very good. Now you can see that bending, there is a little tube over there. Can you see the tube?
Yes.
Yeah, this one. Can you see it?
Yes.
Okay, maybe I have a better picture. Let's see. Yeah, that is a good picture. That is my diagram actually. I wanted to do that. Here is the notochord. Here is the same ectodermis, and now it's the tube is forming, and that's the neural crest. You got it? The same thing, my diagram is the same one over here. Only thing I did not draw over here is a little bit over here. This is the notochord, it's attracting. This is the direction is attracting, making this tube. This is the neural crest cells. This is the neural tube. On the top is the skin. Very important to appreciate that. Now, I want to go forward a little bit by saying that what are the cells coming out from the neural crest? Very important. And I told you that these are the cells. Please remember the facts over here. This is you have to memorize, unfortunately. We ask in the exam that, say, we'll say melanocyte for you know by now, probably, I don't know whether you know it, melanocyte, have you heard the name?
Yes.
It's coming in the skin. So it's coming from where? Neural crest cells. It's not a neural tube. Neural tube is for the brain and the spinal cord, but the neural crest is forming the specialized cell. It's very important these days. Research-wise, this number one priority is to understand how the neural crest cells are helping to complete the system. I give you an example. It's written over there, ganglion, somewhere, must be written. First one. See how important is the ganglia. For example, you have a beautiful, good-looking intestine. The baby is born with a very nice intestine. You think the baby is normal? No. That is not working because there is no ganglia. Why there is no ganglia? And there is this called congenital megacolon. So what will happen? Baby is drinking, nothing is coming out. Tummy is like this way, nothing is coming out. Because there is no ganglia, so the neural crest defect. Congenital megacolon. Very common problem. The baby is born, but the intestine is not working because there is no ganglionic cell. This ganglionic cell is coming from the neural crest cell. So there are many defects could be associated with this. So let me recapitulate one more time. I'm not going to show any more slides. But I want all the students to read my, whatever the slide number this one is. Just go through these slides, all of them. Try to understand. It's not a rocket science I have written over there. It's taken from the book. I explain whatever is needed for you to understand. I want tonight, whether you are happy or whether depressed, whatever it may be, but read it, please. Read it, please, before you come to the next class next week. So let's recapitulate one more time, what I'm trying to do. I'm trying to do for today, just give me 2-3 minutes. I was trying to do the 3 to 8 weeks development, we call gastrulation. Yes. Gastrulation is important because of the differentiation of the cell. Gastrulation is important because of the organogenesis. All the organs are formed from there. And how the organs are formed? They are coming from the germ cells, we call germ layer, sorry. It is called ectoderm, mesoderm, and endoderm. Coming from one layer of cell, that is the epiblast, which is basically your stem cell. So under the influence of the WNT gene or the TGF, transforming growth factor, the cells disintegrated, but under an axis, which is a notochord, the cells go here and there. Some cells fall down to form mesoderm, some cells form, replacing the hypoblast to form endoderm. By now you should know the ectoderm is responsible for the brain and the spinal cord and the skin and the neural crest cell. The endoderm is intestine, and in between this and this, whatever is the mesoderm, which I have not talked to you yet. Then I explained to you how the neural tube is formed. It is formed because of the dragging of some genetic marker. I will come to the next time. Somebody got a Nobel Prize on that. It's called, I won't talk about that, the gene. So that actually pulling it and making a tube. And the tube is forming finally the brain and the spinal cord. Okay? Then I told you the importance of the neural crest. That is my last slide over here, showing you that what are the cells coming out from the neural crest. Okay? I know that you are already very tense, so I'll give you all present today, so don't worry about that. But I request that you please come back with a little bit of reading. Thank you very much.